All right, so again, we are looking for two things. We're looking for the slope and usually the intercept, but sometimes some other coordinate point. Okay, and again, here's our strategy while I'm pasting this in. Our strategy is the same as it was for the what now looks incredibly easy graphing problems like this. I am looking for where to put my first dot. All right, I put my first dot, in this case I put my first dot at 8. And then I use the slope to tell me how much to go down and how much to go sideways. All right, so my strategy is to put the dot where it starts, put my first coordinate at some kind of a point, and then from that dot, use the slope to calculate how much I need to move. Okay, so I'm going to do the same thing, but I'm doing it from word problems. So let's do it for Siraj here. Now, the easiest one that almost always has a keyword is the slope. Because the slope is a ratio, it always has the word each, every, or per. Siraj took a slice of pizza from the freezer and he put it in the oven. Okay, so Siraj has put his pizza into the oven. The oven heated the pizza at a rate of 7.5 degrees Celsius per minute. So this pizza goes into the oven, and the rate that says how hot it gets, it starts off being frozen, then it gets hotter at a rate of, more warm, at a rate of 7.5 degrees per minute. So every minute this thing gets 7.5 degrees hotter. Okay, now it reached the desired temperature of, okay, so this looks like it's giving my coordinate. In other words, where I can put my first point to start with. So it reached the desired temperature of 80 degrees after 12 minutes. So in my strategy, I'm going to place my first points at the coordinate that I desire. Now that desired temperature is 80 degrees after 12 minutes. And I'm going to start asking some questions. Which axis am I going to put this point on for 80 degrees? I want 80 degrees in 12 minutes. So what axis is the degrees? X or Y? Yeah, so what did I want again? The desired temperature. Where am I putting this thing? Robert, where am I putting my first dot? Not 60. 80 degrees after 12 minutes. Okay, so my first coordinate goes 80 degrees here after 12 minutes. So is this correct or incorrect? I wanted Vanessa, is this point at the right spot or not? No, it wanted to be 12 minutes and I put it at 13. Okay, so there is my first coordinate at 80 and 12. Now I can use the slope to tell me what the rise and the run was. So let's look at the slope again. So the slope was 7.5 per minute. What could I times that by to give it a nice round number? 2? Yeah. So in 2 minutes, it would be how many degrees? Okay, twice 7.5. Okay, I'm going to pause. Okay, so we know that it's going to go 15, what am I doing, B? 15 degrees. And that's going to be the rise in 2 minutes. And that's going to be the run. So I'm going to set up a triangle that goes up and down 15, and then the run left and right is 2. And then that means I'm going to have a slope of 15 over 2, which is 7.5. All right, so here I am setting up my triangle. So I know that this coordinate point was at 80, 12, and then 15 degrees, so 2 minutes. How much time is 2 minutes before 12 minutes? So where do I want this dot? I want it right there? So I want 2 minutes away from 12. Where do I want it? I want it at 10. Okay, so I'm somewhere right here at 10 minutes. And where am I on 10 minutes? Well, I'm 15 degrees lower than that. So 15 degrees lower than that would be right here at 65. It looks like I just accidentally got in the right spot right there. Okay, so let me snip that, and then we can draw the slope triangle to prove that this is what this is doing. And so I'm going to draw my slope triangle just to prove this to you. So my first point is where I wanted it. The first point was 12 minutes. It was 80 degrees. All right, and then the slope triangle went like this. So the run here from 10 to 12, the run from 10 degrees, that's a little bit too broad. From 10 degrees to 12 degrees, the run between those two was 2. So the run here is 2, 1, 2. And then the rise from 65 here to 80 here, the rise was 15. And so the rise over the run was 7.5 like I wanted it to be. Okay, so just like I wanted to, I had a point that started at 12 minutes and 80 degrees, and my slope was 7.5, and so everything is right with the world. So let's try it. Hopefully I get it right. I got it right. All right, here comes Sean and his slushie. Sean is drinking this. What happens when you drink a slushie as fast as you can? Okay, Sean is in trouble here. Incidentally, the reason that happens is that your mouth it gets too cold, so it sends blood to your mouth to warm it up again, and that takes blood away from your brain. So Sean has a brain that doesn't have any blood right now. And then here's Sean, more of Sean. He's kind of scary. Okay, so Sean is drinking his slushie, and the easiest thing is to find is the slope, because I'm just looking for the word each, and where's the word each? Or every or per? Yes. Okay, yes. I have a couple of people who've got it. Jesus Escalante. Where is the word each? Sean drank a slushie as fast as he could. He drank 5 milliliters of slushie each second, and he finished the whole slushie after 50 seconds. Where is the word each, every, or per that indicates which of these key numbers is the slope? Which one is it, the each? The slushie each? Okay, and which of these numbers, 5 or 50, is the slope? Yeah, 5. 5 milliliters per second. Okay, that's the slope. Now he's going to finish all the slushie after 50 seconds. So how much slushie does he have left? Let me look at the graph for the variables that we have here. All right, so he starts with a full slushie, like he starts with this much slushie, and then where would he run out of slushie? Like how many milliliters of slushie does he have when he runs out? Okay, here is a graph. He's running out of slushie. When is he going to run out of slushie? At 0 slushie. Good, I appreciate the 0 slushie comment. I appreciate that. Okay, so the coordinate that I have is, here's the coordinate. The amount of slushie is 0 slushie. Okay, so I go to 0 slushie, and then what is that in time? 0 slushie when? I ask these questions and it's just like, I'm just not getting... Alyssa Padilla, when does he have no slushie? Yes, 0 milliliter slushie. What amount of time does it take him to finish his slushie and have no slushie? 50 seconds. Okay, so my coordinate that the problem gave me is 50 seconds and 0 slushie, and then I want my slope to be decreasing because he's using up his slushie by 5 milliliters each second. Okay, so here's my graph. Now, my first coordinate is 0 and 50, so that's right there, right? Okay, so my first coordinate right here is no slushie is 50 seconds. What did I do wrong? How much slushie did I just put? What did I want? I wanted 50 seconds. Where's that? 50 seconds is the x-intercept out here. Okay, so he has no slushie after 50 seconds. Okay, and then he loses 5 slushie. He loses 5 slushie, but let's see. Let's see if this would work. So it's 5 milliliters every second, so how much in 5 seconds? 25? So I could set up a slope triangle that went down down 25 every time it went sideways 5, yes? That would be 25 over 5, which would be 5, the slope that I'm looking for. So it goes down 25 every time it goes sideways 5. Okay, so down 25, sideways 5. So you can see that this is 25, so it goes down 25, sideways 5. Or you could say down 50 for sideways 10. Or you could say down 100 for sideways 20. So those are all the same. They all give you... Let me prove to you what I'm doing here. I feel like I'm blowing your mind again. Okay, here is the slushy graph. Whoops. Okay, I wanted to run out of slushy out here after 50 seconds. So that for sure ran out of slushy. Okay, and then let me check my slope triangle. What was the rise here between 0 and 100? The rise. No, not 4, between 0 and 100. So this is 100 and this is 0. Okay, from 0 to 100, what's the distance? The distance between 0 and 100, the difference between 0 and 100 is 100. Okay, and then how long did that take? The difference between 30 and 50 was 20 seconds. Okay, and then let's check that. 100 milliliters in 20 seconds was 100 divided by 20 is 5. And did I want 5 milliliters per second? Yes. Yes, I did want 5 milliliters every second. Okay, so this again is a good slope triangle because it goes up, down 100 and sideways 20. Okay, one more. Let's do another one. I know you guys are loving these. Wilbur's landing his plane. Okay, please, I want somebody to tell me what the... Let's just write down the strategy, okay? I'm not going to solve this. I'm going to write down the strategy. What is my strategy? I'm looking for what? What kind of things am I looking for? Jonathan, what's my strategy when I look at these things? I start off looking for the easiest thing to find. What is it? Go, Jonathan. Start by finding the slope. What do you look for to find the slope? A rate, and then you look for the keywords. Each, every, or per. Okay, so step 1, find the slope. Step 2, he reached the ground after 15 minutes, so find your coordinate. Okay, how high is the ground? We spent a long time talking about this last time. What is the elevation of the ground? Okay, if you're in the air, no meters, if you don't jump off the air at all, where are you on the ground? 0. Yeah, 0 is on the ground. Okay. So my coordinate here was 0 kilometer elevation and then 15 minutes. Okay, so the point was 15, 0 where I started, and then the slope was 0.2, and then you can times that by 10 to make it into 2. So that means it's going to start at 15, or the x-intercept is 15, and then it goes down for every 10. Every 10 this way goes down 2.5, okay? It goes down 2 or 2.5? It goes down 2. There. All right, I've set up a problem that has 10 this way and 2 this way, so that has a slope of 0.2, and the coordinate out here is 0 elevation in 15 minutes. All right, so there's that one. Okay, again, so your strategy is find the slope, find the coordinate, and then when you're graphing it, you put the first point wherever the coordinate is. So if it told me my elevation was 2 after 15 minutes, then I'd start there. And then you can set up your slope to have the right kind of slope triangle by counting. In this case, you would count down 2 and sideways 10, and that has the slope that you want of 0.2.